Hello everyone, welcome to part 3 for the 6.1 notes about solving systems of equations with matrices. Right here we're going to see an example where we will read a word problem, we will make the matrix that we're going to use to solve this problem, and then we will solve the matrix. In this case we will probably be using some type of Gauss-Jordan elimination. That's basically a good way to go. So here, this problem, it has to do with a concession stand that sells hamburgers, hot dogs, and drinks. And we have 3 patrons. It's calling them here patron 1, 2, and 3. Patron 1 spends $11. Patron 2 spends $5 for the food. And the price of the food for patron 3 is $22. So it says here that X, Y, and Z are going to represent the cost for hamburgers, hot dogs, and drinks, respectively. And I think by the wording here it says that they're paying such an amount of money for food, but we can tell based on what they purchased that actually they all bought drinks as well. So by food it simply means, in this case, consumables, where drinks are also being considered food. And so I'm sorry if that's confusing, but we have already that X is going to be the cost of hamburgers. Each hamburger will cost X. Also, each hot dog will cost Y. Cost of a hot dog. And then Z is going to be the cost of a drink. And so what that means is that basically whenever we multiply how many hamburgers someone bought multiplied times X, that will tell us how much they spent on only hamburgers. And when we multiply how many hot dogs someone bought multiplied times the cost of each hot dog, we will get how much they spent on hot dogs. And then similarly, when we multiply the number of drinks that someone bought times the cost of each drink, we will get how much money they spent on drinks. And so we will have a system here that has an equation for each patron, how much they spent in total. And so let's make that one. We will say total spending of patron 1. That will be one equation. And how much did patron 1 spend? He bought 1 hamburger. The cost of a hamburger is X, so basically he spent 1 times X on hamburgers. He spent 1x. I'm just going to write 1x for now, even though normally we would just write x. And then he also bought 1 hot dog, and so plus 1 times of y, he will spend this much on hot dogs. And then he bought 5 drinks, and so it will go plus 5 times of z. That's how much he spent on drinks. And then we have in our little thing here that patron 1 spent a total of $11. So we would want to say here that the total amount that he spent was $11. And then we would do the same thing for patron 2. We also will do the same thing for patron 3. And then we will get our system over here. We will convert it to a matrix, and then we will be well on our way. So let's see about patron 2. Patron 2 did not buy any hamburgers, so the amount that he spent on hamburgers is just 0. He spent 0 on hamburgers. Another way to think of it is basically 0 times X. He bought 0 hamburgers that each cost X, so he will eventually, when we multiply these, he will have spent $0 on hamburgers. And then he also got 1 hot dog, the same as patron 1, and then he got 2 drinks, so 2Z. And then how much did patron 2? Patron 2 only spent $5 in total. And then patron 3, he got 3 hamburgers, so 3 times the cost of hamburgers is how much he spent on hamburgers. He got 1 hot dog, so plus 1y. And then he got 11 drinks, and so plus 11z. This is going to be, how much did he spend? He spent $22 in total, so this will equal 22. And now that we have our system of equations, we can convert this one to a matrix. If you can remember back to previous videos how we would convert this one to a matrix. We're just making basically here a coefficient matrix, as it were, where we need the coefficients for x, y, and z to go in the first, second, and third columns, and then we will make it augmented by having this kind of a dotted line where the equal sign goes. So the first equation has 1x, it has also 1y, and then it has 5 z's, and these all together make 11. And then the next one, there are no x's, there is 1y, and there are 2 z's, and then this will equal 5. And then for the third equation we have 3x, we have only 1y, and then we have, in this case, 11 z's, and this will eventually equal 22. So here we have it. This is going to be the matrix that we're going to use to solve this one, and now it's just going to be a matter of solving it. And so it can be a little bit troublesome here trying to figure out what to do first to start solving this one. Which type of elementary row operation should we do first? But remember what we're trying to obtain. We're trying to obtain, I'm just going to say eventually, actually I'll write it this way, we want eventually a matrix that goes ones on the main diagonal. We want to have zeros below the main diagonal, and then we want to actually have also zeros above the main diagonal. And then on this side, we don't know what's going to be here. If we knew what's going to be here, we wouldn't have to solve anything. So we want a matrix like that. Now, the first step of what we would want to do, we should get a 1 in the desired location for each column, starting from left to right. So in this case, in column 1 to begin with, we want to get this 1 that's right here. That should be the first thing that we would want to do. Get this 1 that's in the top right. And then step number 2, we will get zeros below that 1. And actually, I would like to say below and above, because here we're just talking about in general, and sometimes we want to get a 0 also above. For example, once we go to the second column, we will want to get a 0 that's above this one. And so we want to get zeros below and above the one that we just got. And then we will basically go to the next column and kind of rinse and repeat. So go to the next column. That's going to be our process, just so that we can stay as organized as possible while we're doing this. So why don't we give it a shot? I'm going to write here our matrix that we're dealing with. It goes 1, 1, 5, and then 11. It goes also 0, 1, 2, and 5, and then goes 3, 1, 11, and 22. So the first thing that we're going to want to do, since we already have in our upper left where we wanted to get this 1, we already have a 1 there, and then we also have already a 0 below that 1. So the first thing that we should try to do is to get this to be a 0, where the 3 is. And it's going to be simple to do it. That's kind of the point of securing this 1, by the way, is that we can just subtract or add different multiples of this row in order to get rid of the coefficients that are below it. So we can get rid of this 3 by taking row 3 and subtracting 3 times of row 1 and making that be our new row 3. So why don't we see what's going to happen. Row 2 is staying the same. We're only changing row 3. So we will keep these ones the same. And then row 3, we're going to take this number and subtract 3 times of what is in row 1. And so 3 minus 3 times of 1 is going to be 0. That's why we did it. And then we have this entry in row 3, the 1, minus 3 times of 1. And so 1 minus 3 basically is going to become negative 2. And then we have 11 minus 3 times of 5. That's going to be 11 minus 15, which is negative 4, is going to go here. And then we will have 22 minus 3 times of 11. So 22 minus 33 This, of course, is just negative 11, so we have that one. And now we are ready for this kind of step 3. We're just going to go to the next column. And conveniently, we're hoping to get, for our Gauss-Jordan elimination, we want to get that 1 that's in this second row here in the second column, because that's the one that's on the main diagonal. That's basically the process we're going for, get these 1s on the main diagonal. We're just doing it one column at a time as we work to the left. So we already have this 1. We don't need to worry about it. We need to get the entry above it to be a 0, and we need the entry below it to be a 0 as well. And so we can do it one at a time. We could actually get this 0 above quite easily. What if we just take row 1 and we subtract row 2 from this one? That's going to basically result in 1 minus 1, which is 0, and we want this to be the new row 1. And so what is going to happen? And by the way, that's why we wanted to get zeros below here, so that whenever we do this process that we're about to do, we're not going to mess up any of the work that we did previously. And so row 1, and we want to subtract 1 time of row 2. So for our new row 1, we will have 1 minus 0 in this slot, which is just 1. And then we're doing 1 minus 1, which is 0. And we're doing 5 minus 2, which is 3. And then we're doing 11 minus 5, which is 6. So that's our new row 1. Everything else stays the same. We have the same row 2 and the same row 3. And then we can pretty easily get this to be a 0 that's below the 1 just by adding 2 times of the second row to the third row. So we want to basically take row 3 plus 2 times of row 2 and make that be the new row 3. That will ensure that we will get this 0 down here. So let's give it a shot. Of course, row 1 is not going to change, and row 2 is also not going to change. And then row 3, this is the one that's going to change. We're taking row 3 and we're adding 2 times of row 2. So 0 plus 2 times of 0, well, that's just 0. We have negative 2 plus 2 times of 1, so negative 2 plus 2 is 0. And then we also have this one that goes negative 4, and we're adding 2 times of 2, which is going to be, oh, actually notice that that one's also 0. And then we have negative 11 times, or plus rather, 2 times of 6, which is negative 11 plus 12 is 1. And I want to stop here and think about what's going on with this problem. We've seen basically how we would go about solving an equation, or solving a system of equations that has a solution. And in this case, we're seeing that apparently this system does not have a solution, because notice what this row actually stands for right here. This stands for 0 equals 1. So we will conclude that there is no solution. I know maybe it seems anticlimactic, but this is going to be a good segue into 6.2, where we're going to talk about these kinds of systems. And so this does it for 6.1. I will catch you guys in the next set of videos for 6.2. Still talking about matrices, but I hope this was helpful. See you later.